are you using this DBC file? And what is this DBC file? Guys, do you remember why we are using this DBC file? Anyone? Hello? Say yes or no. Don't be silent. Are you aware of why we are using this DBC file?
No, sir.
Okay. Others? No? What about others?
Ravi, voice is not clear.
Voice is not clear, huh?
No. How you joined? Tab or laptop?
Laptop on there.
Okay, Rasul, are you able to hear clearly? Clear వినిపిస్తుందా? Ravi, check once again.
Okay.
Yeah, you continue now. It's okay.
Now is it audible?
Yeah, yeah.
Okay. So my question is like we have seen, right, this DBC file, CAN database, right? Yes or no?
Yes, sir.
So what all information will be there in this CAN database file? Related to CAN messages, what all signals are there? What is the DLC? What is the message ID? Correct, na? And signal layouts, mapping of signals in the message. Correct, na? Yes or no? So this CAN database is used for designing and developing the network, right? CAN network in the vehicle. Correct?
Yes, sir.
Forgot, huh? Don't remembering. Guys. Okay, no problem. We'll see it again, okay? So this is CAN database file, okay? So CAN database file actually will have all the network CAN network related information present in it. Okay. Let's say if we'll talk about
Ravi, record it.
messages.
Record it.
Just a minute.
Recording in progress.
Yes. So this CAN database will have all the CAN network related information. Okay. This will be the input for developer. Developer is going to take these information to develop the CAN network, as well as for testing team also, this will be the input. Okay, because see, the developer has developed a product. Okay, so let's say it is an ECU, any of the ECU. Take an example, power steering, maybe brake control. Okay, so this power steering or brake control ECUs are there that has to work on the CAN network, right? Correct now? They need to communicate with each other. I already did that. Anji, Gopi, already I started recording.
Okay, sir.
Okay. Yep. So this information is required. Okay. And this information will come from where? Who is going to give this CAN network related information? Who is the owner of this vehicle network information? Anyone? Is it the supplier or OEM? Who is responsible for developing and designing the vehicle network?
OM, sir.
Yeah, OEMs are responsible. They are the owner of complete vehicle, right? So the vehicle network is there. The network which is used by all the ECUs to communicate between each other. That is the responsibility of OEM to design and develop, right? So the complete vehicle network will be defined by the OEM, how it should work, which protocol to be used, what should be the kind of a speed of CAN or maybe LIN or any other protocols are being used in the network. So these definitions are provided by the OEMs. Okay. So now, once let's say we started working in one of the ECU, let's say maybe powertrain or maybe power steering or it can be brake control module or airbags, whatever. Okay. So for developing or designing that ECU, we need all the input or we can say all the requirement from the customer. Who is the customer here? OEMs, right? Because they are only responsible. They will say, I want this ECU. It should be working like this and the size and shape, it should be like this. It should be fitted in this location. So they are going to provide all the requirement. Correct now? Guys, am I right?
Yes, sir.
So now, if we are designing and developing that ECU, if we'll talk about vehicle, it has to work with the other ECUs, right? It has to communicate with the other ECUs. Correct now? Because no ECU is going to work standalone in the vehicle. All are kind of dependent on each other for the information. Yes or no? Guys, no ECU is going to work independently, right? All are dependent on each other for passing the information between or sharing the information between them. And this sharing information is happening using what? Communication protocol, or we can say communication network, right? Correct now?
Sir.
Yeah. So if we'll talk about, let's say in the vehicle we have CAN network. So all related information related to the CAN network will be provided in this CAN database file. If we'll talk about, let's say, messages. So if this message is there, what is the name of this message? Is it a standard CAN or extended CAN? So it is standard CAN. What is the message ID? The message ID is 0x534. What is the data length code? So it's 8 byte. Transmitter, who is the transmitter? It ACU. Okay. What is the method of transmission? It's cyclic with 100 millisecond of cyclicity. Correct now? Apart from that, now we have in that message what all signals are there. Okay. Signal are generally the information which will be mapped to the message and being transmitted over CAN network. So signals, if we'll say, these are the actual information mapped to the messages. and that we can see in layout. Okay, this layout will tell which signal is mapped. See, this layout is like the DLC length of this message is 8 byte, 0 to 7. Okay, which is the data field of CAN. Correct, huh? In CAN data field, how many bytes of maximum bytes of message, byte of information can be transmitted? 8 byte. Correct. Here for this message, what is the DLC? 8. Maximum DLC we are using. And those signals will be mapped in that 8 byte of DLC. How the mapping is done? That will be explained in the layout diagram. Byte 0 is mapped with CRC signal. Byte 1, 4 bits or 1 nibble we can say mapped with clock ACU. Here 2 bits are mapped with active hood malfunction. Here 2 bits are mapped with active hood warning indication. So like this mapping of signal on 8 byte of data, you can see it here in layout. Okay, because see, in CAN, these signals will not be flowing. Message which has 8 byte of data, right? Data field we can say 8 byte of data which is flowing in the CAN. Now we need to decode once the receiver receive this information, this 8 byte of data. So now that receiver has to decode which in that all 8 bytes, which bits are having which information. Understood? That has to be decoded, right? So how this decoding will be done? If we doesn't aware of this layout, how do you think the receiver will decode? How do you think receiver will take byte 0 as CRC information? Byte 1, 4 bits as clock information. Byte 1, these 2 bits, 10 and 11 bit as active hood malfunction information. This 8 and 9th bit as active hood warning indication. How does the receiver will come to know which information is there in which byte, which bit? If we are not aware of this layout, do you think is it possible if you're not aware of this layout and you'll able to decode the information? Is it possible? Guys?
Oh, sir.
Correct, now? You need to know if transmitter is transmitting some information, kind of it has encoded that information. This bit is this signal or this information. The receiver also has to decode that. And how the receiver will able to decode? It should have also the same information. This byte, this bit will be this signal information. Correct? If receiver and transmitter both are aware of, then they can able to encode and decode the information. So that's why this CAN database information is very much important from development point of view as well as testing point of view. Because first it has to be developed, then it will go for testing. And for testing also, how you will test if you doesn't have this information? Are these messages are correctly encoded or decoded or not? The transmitter is transmitting some information. Is it the correct information? How do we come to know? So that's why this database is very much important from development point of view, from testing point of view. Got it my point? So if you see who is the transmitter of this message, who is the receiver of this message, we'll have layout diagram, we'll have all signal information. If you want to see detail about any of the signal, let's say if we'll talk about this signal, so you can see here this signal name, how many bit it length is, what is the factor, what is the minimum maximum value, what is the offset, what should be the initial value. All this information will be present in this CAN database file. Each signal by signal, each message by message information will be there. Got my point? Guys?
Yes, sir.
So see, if you'll see this message, sorry, this signal, passenger alert state, okay? So it is 2-bit length. So the maximum value will be 0 to 4, right? Correct, na? It is 2-bit. If you'll see in value description, 0 SB not monitored, 1 SB unfastened, 2 SB fasten or passenger absent, 3 unavailable. So you have 0 to 3 information using 2-bit. So likewise, you will get all the information related to signal, related to message, which message this signal is present, what is the message ID, how much is the DLC length, from which bit this information starts. Okay. If we'll talk, this is 2-bit length. It starts from 16-bit. Got it? So all the information will be present in this database file. And based on this database file, developer is going to design the CAN network, okay? And tester is going to test it. Understood? Guys? Yes or no?
Sir. Yes, sir.
So just try to explore this, okay? So you'll have different messages. This is present in the PC, what is there in the classroom, right? Just try to explore, try to get familiar, what all information are there. Just check, try to explore, okay? Correct now?
Okay, sir.
Fine. So this at least got some idea, right? About this database, CAN database file.
Yes, sir.
Okay. So now we'll continue about this canalizer. Okay. So today we'll see canalizer. Next week I will start again back to the UDS. First, I just want you to understand why this CAN testing tool is required. Okay. So that you'll get the scope if you are using this CAN testing tool, what you can do with respect to UDS, with respect to CAN network. Okay. So that's why I just want you to get understanding about the CAN testing tool. So yesterday we have seen, right, what is the use of canalizer, why we are using canalizer tool. Can anyone? 3 points I give you, right? Guys? Yesterday I gave, no? 3 points. Why we are using canalizer.
Yes, sir.
What are those?
Simulation of CAN message,
Yes. Simulation of
Monitor-
CAN message.
monitoring CAN bus,
Yes.
performing UDS testing.
Yes. So now simulation of CAN messages, I explained you yesterday, right? Why simulation of CAN messages are required. Why is it required? Guys? Why we need simulation of CAN messages? Guys?
Forgot that.
Is he? Sorry? Anyone telling something? Guys, we have seen now, like see, any individual issue cannot work independently, right? Let's say, if we'll talk about one issue, which is, let's say, power steering, EPS. We have seen now example. Guys, it cannot work independently, right? It needs some information from other ECUs, right? Yes or no?
Yes, sir.
It need information from other ECUs over CAN bus. Correct, na? So here we have CAN bus. Using this CAN bus, the information from other nodes will be flowing on the CAN network. These information are required by our EPS ECU to process, correct, na? To do the processing. Yes or no? Guys,
Yes,
we
sir.
have seen, right? Previous class, we need what all things required. One, we need a power supply, correct? Yes, na? We need a power supply unit. We need some sensor. We need some actuator. Guys, do you remember?
Yes, sir.
We need some sensor, correct, na?
Yes, sir.
We need some actuator.
Actuator.
And apart from that, we need a power supply and we need a CAN bus, CAN information, right? Based on all these things, this ECU will process the data and will do whatever it intended to do. Yes or no? Guys,
Yes, sir.
if we'll talk about a power steering, it required vehicle speed information, right? Correct, na? It required ignition state. It required engine status or engine speed, we can say. It required yaw rate information. Correct, na? It required different information. Based on that information, that ECU is going to process or do its intended task. Yes or no?
Yes, sir.
Everyone, do you agree? Guys, are you agree with my statement?
Yes, sir.
So now, let's say our development team has worked very hard to develop the EPS ECU. Now it will be sent to the testing team, okay, for testing it. So now just tell me, how do a testing team will work if they doesn't have this CAN environment? We can able to manage to get power supply, right? Power supply we can buy from outside, correct, na? Yes, right?
Yes, sir.
Sensor actuators also fine. It's not a problem because sensors will be there with the EPS when the integration will be done, the hardware and software integration. So at that time, we'll have the complete sensor and actuators integrated with the ECU. So this will be there. Not a problem. This power supply also we can buy from outside. It's not a problem. For power supply, we doesn't need to have vehicle. We can buy a power supply unit and we can connect to the ECU for standalone testing. Now, what about this CAN bus? How we can get this information? Because we doesn't have the vehicle, right? Guys,
Yes, sir.
and how we'll get this CAN bus? We need to have some tool, right? Which can simulate all the CAN messages which is required by our ECU, like vehicle speed, yaw rate, engine status, engine speed. Correct, na? Yes or no? Guys,
Yes, sir.
understanding what do you mean by simulation? Guys, what do you
Yes,
mean
sir.
by simulation? Did you understood? We doesn't have this actual vehicle network, right? Because we doesn't have the complete vehicle with us. So this complete CAN bus will be kind of a simulation we are doing, so that whatever the signals our EPS ECU required for processing its work, we will simulate over CAN bus to the EPS ECU. So what we'll do is, here this CAN bus is there, right? So what we'll do is, instead of this CAN bus, we'll remove it. Okay. Instead of this CAN bus, we'll connect a CAN test tool. Okay. And this CAN testing tool will be connected to our PC. Okay. Our computer. This will be connected to our PC through USB. Okay. And in our PC, we will run this canalizer tool, which is using that canalizer tool, we are simulating CAN messages. In this PC, we'll simulate, will transmit to the hardware, and this hardware will transmit on the CAN network. And then this EPS ECU will receive that information. Okay. So that is the purpose of this. Can you see the canalizer tool, guys? Is it visible?
Yes, sir. It's visible.
Yeah. Can you see here this CAN, this part?
Yes, sir.
So this is actually the CAN driver. Okay. So we can say, using this tool, this software on the PC, we can simulate the CAN message. We'll send from here, we will send to the virtual CAN. This virtual CAN is nothing but that hardware is there, right? In the diagram. We have this CAN case XL. So through PC, through virtual CAN, USB, it will be transmitting to the CAN case XL. And this CAN case XL will transmit on the CAN bus to the EPS ECU. And this EPS ECU will receive the CAN messages. Got it? Guys?
Yes, sir.
So here, now the canalizer is visible, right?
Yes, sir.
Yeah. So this portion is used for sending the message, or we can say simulation of the CAN messages. This whole portion. Okay. We can add here, let's say, we'll add a kind of a interactive generator block. Okay. So this IG block is used, or we can use a CAPL script programming node to simulate the CAN messages. Okay. These CAN messages will be sent in the form of message to the hardware, and through hardware over CAN. Now we can select the baud rate based on our configuration. Okay. So here we have selected 500 kilowatt per second. So then this will go to the hardware, that CAN case XL. I have shown now diagram. Do you remember CAN case XL? Just a minute. Let me show it again. Okay. Is it visible?
Yes, sir.
So this is the hardware. Okay. This hardware is called CANcase XL. Okay. This front, you'll see two channels or one channel or four channel. So these are nothing but individual CAN channels. Okay. So this is CAN 1, CAN 2, if you'll say. So the uh, like the ECU is there, right? So ECU will be connected to these channel through CAN bus. Okay. Backside will have this USB cable. This will be connected to the PC. Okay. Understanding, guys?
Yes, sir.
And this CANcase XL will be front this 9 sub connector, D sub connector, 9 pin. Okay. This will be connected to the ECU, and this is nothing but the CAN. Okay. So using our CANlyzer tool on PC, we can simulate the message. This message will come to the hardware CANcase XL, and it will be transmitted on the CAN. And through CAN, it will go to the ECU. So in this way, we are using this CANcase XL or we can say CANalyzer for doing CAN simulation. Got it, guys?
Yes, sir.
So fine. For now, just try to understand. Okay. Now we'll see how you are going to simulate the CAN message. Then you will get more understanding. Okay. Using this tool, how you are going to simulate the CAN messages. Understood, guys? Yes or no?
Yes, sir.
Sir.
So this area is used for CAN simulation, sending the CAN messages on the CAN bus. This area is used for monitoring the CAN. Okay. This area you can see, right? This area is used for monitoring the CAN bus. So in CAN statistic, you can see how much is the bus load, what is the timing parameters. So those things you can electrical parameters you can see in the CAN statistic. I will show you in detail. Okay, once we'll run this, I will show you in detail. Just try to understand for now. This area used for CAN simulation. In this area, you can send messages on the CAN bus like this. It will be, the message will be sent. It will go to the hardware onto the CAN bus with how much baud rate? 500 kilobaud. Okay. This you can see the feedback. Whatever you are sending through the CANlyzer, that also you can monitor in the trace window. This will come the input. Okay. Whatever messages are there in the CAN network will come here and you can monitor. Understanding, guys?
Yes, sir.
Okay. So you can monitor here using these windows. You can transmit using this. Okay. Now we'll see one thing. We'll create a configuration file. Okay. A new configuration for CAN. So we'll see. We'll create a new CAN configuration. Okay. Based on our requirement, we can use, if you want to create for link configuration or most configuration, or you want to configure for FlexRay or for Ethernet, you can do that. But currently we are looking into CAN. So we are just creating a configuration file for this CANalyzer on CAN network. Okay? Understanding now? So we are creating a CAN 500 kilobaud one channel only. Okay, guys,
Yes, sir.
it's understandable. If you want to create for two channel, that also can be done. But first we'll see for only one channel. So one channel means, can you see the CANcase XL?
Yes, sir.
So only we are using this configuration, only one channel is used. Another channel is left blank. This is not in used as per our configuration. Okay. If you are going to select two channels, then both these two channels will be used. So both channel means there are, just imagine one microcontroller having two CAN network, two separate CAN transceiver. So each will be taken as a separate CAN transceiver. Understood? Channel means this. Guys, understood?
Yes, sir.
Channel means one separate CAN transceiver which can be connected on CAN network. Two channel means same microcontroller, it has two CAN transceiver. So this is not a microcontroller, this is a CAN case hardware for CAN simulation. I'm just taking an example of a microcontroller. So assume one channel means in a microcontroller you have only one CAN transceiver. Okay, two channel CAN 1 and CAN 2, you can say like you have worked right in UART. In UART you will see na UART 1, UART 2. Guys, do you
Yes, sir.
remember when you have done coding for UART configuration?
Yes, sir.
You'll have multiple UARTs in one microcontroller, right? Maybe 1, 2, and 3 also.
1, 2.
UART or UART 0, UART 1, and UART 2. Correct?
You
Huh?
go. You are one. You are one.
Some microcontroller you'll have 3 or 4 channels also. Some microcontroller only UART 0, UART 1. Correct? Na?
Yes, sir.
So likewise, if it is talking about CAN 1, CAN 2, that means you have two CAN transceiver implemented. Okay. And both will be acting as a separate CAN channels. Understood?
Yes, sir.
Okay, good. So now we'll come here. So currently we are just doing configuration for one channel with 500 kilovolts. Okay. So we'll save it somewhere, this project. Okay. Save it. Created one folder. Okay. So in this folder, I'm going to save this configuration. Okay.
Okay.
Fine.
Okay, sir.
Yeah. Now this configuration has been saved and we are using here CAN channel 1. Can you see here? Others we are not using. So others are left as it is. We have selected configuration CAN channel 1. Only one channel CAN. Clear?
Yes, sir.
Now, here we need to use this for CAN simulation. Now CAN information, where I can get all the CAN related information, where I can get guys, from where we can get the CAN information? CAN database, right? Forgot? DVC file. Guys,
Yes, sir.
forgot, huh? Morning only seen, right? Not morning, just half an hour back. We have seen, na? Guys,
Sir.
so that CAN database will be the input for this Canalizer tool as well. So here in CAN channel, add database. Okay, just go to CAN channel 1, add database. It will ask where you want to. I will go to DVC file and I will select a DVC file. Okay. So now my CAN database file is mapped here. Understood? Guys,
Yes, sir.
this is required. Why? Because you are going to work with CAN. How you will do that? You need to have CAN database information. If you'll add that CAN database file here, it will import all the message, signal, all related information. This Canalizer tool automatically will import those information. Now, this portion is used for simulation of CAN messages, right? Do you remember? I told earlier. Yes, now?
Yes, sir.
So here simulation can be done using two ways. One is using CAN interactive generator, IG block. Okay. Or you can use programming node. Okay. Using programming node, you can do the CAN simulation, or using CAN IG block. For programming node, we will talk later when we'll go for CAPL script. So we'll remove for time being. Now we'll see how using CAN interactive generator block, we can able to simulate the CAN messages. Understood? Guys, understandable?
Yes, sir.
Everyone? Yes or no? Guys,
Yes, sir.
not understood?
Understood, sir.
Understood, na? So using two ways, we can able to simulate the CAN messages. First one is using CAN interactive generator block. Another way is using programming node. For programming node, we need to write CAPL scripting. We need to use CAPL scripting to do that. That also we'll see later. For time being, just our focus is to understand this Canalizer tool, how it works, what all things you can do. So we'll talk on CAN IG block. Later we'll go for CAPL script. Okay, guys. Once the UDS is over, we'll go for CAPL scripting. Okay, now. So,
Yes, sir.
yep. So now we have used this IG block. I have opened this IG block. Now, you want to send or you want to simulate a CAN message. Simple. Add frame from database, because we had already selected the CAN database here, right? We have selected earlier. Because of this, all the CAN database related information will be available in Canalizer tool. So if you want to simulate, right click, add frame from database. Now this will show what all message information are there in the database. These all messages are there. Now out of this message, which message do you want to simulate? So let's say I want to simulate this, and maybe I want to simulate this. Okay. So I selected from database these two messages I want to simulate using Canalizer. If you want to add more, again go. Add frame from database. Let's say maybe you want to simulate this also. So we can add. How many messages you want? You can add from database. Just go add. Just go add. Understood? Guys?
Yes, sir.
So what? This is the easy way. Okay? If you are not adding, let's say, in the database management if you'll remove this database. Okay. Now what will happen? If you'll open the IZ block, these all information will be gone. Now, if you want add from database, we doesn't have any information. Understood? Guys? Because we doesn't have the database. Now our work you can able to do. Still you can able to. But manually you need to. Manually you need to type message name. Manually you need to type message ID. From which channel, what DLC, everything manually you need to do. It's a hectic job. But if you will add database, if database is there, go to IG block, simple. You will have all the message information, pick, simple. All the information will be imported from DBC file here. You doesn't need to add manual name, ID, which channel, or what DLC, or even you can see the signal information. For this message, which all signals are there, and which signal you want to change the value, you can do it here. Understood? Now let's say add one more. So let's say we'll add one more. Okay. For this message, these three signals are there. If you want to change the value, you can change it here. It's easy. If you add the database file, it will be easy. The job will be very easy. Understood, guys?
Yes, sir.
Yes, sir.
Okay. Now we have ready with the IG block. And we need to transmit. How you want to transmit? This message is being, if you'll see the database, okay? I will open the database file. What is the message? BCM A115, okay? Just a minute, I'll share database.
Okay, sir.
So this database is visible, right? So this message we are simulating using Canalizer, okay? What is the cyclicity here? Guys?
1000.
What? 1000 millisecond, okay? So you need to refer database file, okay? Now, for this message, the periodicity is 1000. Is it visible, Canalizer?
Yes, sir.
Yeah. So select here, instead of manual, do it periodic. And what is the cycle time? 1000, right?
1000.
Correct now? Selected. Now this message will be transmitted with periodic 1000 millisecond. Now run the Canalizer tool. Okay. I am running it. Now if you'll see in trace window, okay, trace window is used for monitoring. We doesn't have any message, okay, in the trace window because using IG block, we have not yet started. Now we'll start sending, okay. Now if you'll see in trace window, can you see here, guys? This message is being transmitted,
Yes, sir.
correct now? And if you see the cyclicity, 15.5, then 16.5, every 1 second, means 1000 milliseconds, this message is being transmitted. Correct now? Guys, is it visible? Clear now? And now the second one also, if you want to transmit, this periodicity is 100. Select 100 and transmit. See, now the second message is also getting transmitted. I'll make a pause. See, this EPS A100 is transmitted. Its periodicity is 100 millisecond. So 4480520. This BCM message is transmitted. Okay. If I'll select the delta T, so this message is transmitted every 100 millisecond, and this message is being transmitted every 1000 millisecond. Clear? Guys,
Yes, sir.
understood?
Yes, sir.
Visible now?
Yes.
Here 64.5. The next BCM is transmitted 65.5 1000 millisecond. Okay. Here EPS is transmitted 64.58, 64.68, 64.78, 100 millisecond every. Correct? Clear now, guys?
Clear, sir.
Clear, sir.
Yeah. So understood what it is happening. So here using IZ block, if you see here using IZ block, we are sending those messages on the CAN. Okay. And those messages which are there on the CAN, we can see here in the trace window. Okay. This. Clear? Yes, now?
Yes, sir.
So at least, did you got some understanding how this is being done?
Yes, sir.
Using this tool, we are simulating the CAN message through hardware to the our ECU, right? This tool is a test tool, right? CAN testing tool. And this tool also can be used for UDS testing, right? Yes or no?
Yes, sir.
What is the input file required for Canalizer tool? Tell me. CAN database, DVC file. Guys, remember, we need CAN database file as the input for Canalizer, right? Or else it will not work. Yes or no? Guys,
Yes, sir.
clear?
Yes, sir.
Good. So that is one of the input. Now, using this, what is the purpose of using Canalizer? Tell me. 3 points I told, right? Why we are using Canalizer tool? Guys, why we are using Canalizer tool?
Simulation of CAN message.
Understood how the simulation is done?
Yes, sir.
Second point,
Monitoring CAN bus.
monitoring CAN bus using trace. Correct, huh? Understood how it is done? How you can monitor using this trace window? Correct, now? Whatever the messages are there in the CAN, you can monitor here in the trace window. Understood?
Yes, sir.
Okay. Detail about Canalizer, we will see later. But now the third point, for performing,
UDS testing.
now how we'll do that, I will show you. Now you understood, right? What is the input file required for this Canalizer? CAN database, right? Now
DVC.
for test, DVC file. .dvc is the extension. Okay. Now, for performing UDS testing or diagnostic testing, you need one more additional file. That will be the input for Canalizer, and that is called .cdd file, Candela Studio or Candela Diagnostic Description file. Understanding? Guys, for performing UDS testing, you need one more file, which is Candela Diagnostic Description file, CDD. Okay? The extension will be .cdd file. Just make a note.
Okay, sir.
Okay? Now, how we'll do that? Can you see here diagnostic tab? Here? Visible now?
Yes, sir.
In diagnostic, first you need to create a diagnostic console for performing diagnostic testing. For that creating diagnostic console, you need to have diagnostic CDD file, Candela Diagnostic Description file. Okay. So here we'll go to diagnostic ISO TP. Okay, we'll click here. Now this will open. Okay. Now we need to create add diagnostic description file. Okay. CDD file. So the CDD file will look like this, Candela Diagnostic Description file. Okay. Like this will be there. We'll open. Okay. Understood?
Yes, sir.
So you want to use physical request or functional request, you need to select. So we'll select the physical request. So using this description file, we are creating a physical request description file. So whatever the message, whatever the request is sent by this client. Now, what is the client here? This diagnostic testing tool, Canalizer. This is the client. Understood? Guys,
Yes, sir.
understood?
Yes, sir.
So using this diagnostic console, if any request is sent, that will be sent using physical request. Understood? If you'll select functional request, then those requests will be sent using functional group. Now, can you see here request to ECU 700 message ID? The response from ECU is 600. Okay. Now for ISO TP, the ST time is 20 millisecond, block size is 0, FC delay is 10 millisecond, and maximum length is 4095. Understood? Here ISO transport protocol configuration we are doing. Understood? We have now flow control, ST, separation time, block size. If block size is 0 means, huh? 0 means consecutive frames will be continuously transmitted. No in between flow control. Got it? Guys, forgot, huh? Guys, CAN TP you forgot. Understood now what I am talking? Block size, separation time, maximum length 4095. You can transmit, right? So these things you can do it. Now digital, here. Aware of P2 client, P2 server time, P2 start server max time. Remember? Guys,
Yes, sir.
these configuration also you can do it here. Okay. So these automatically it has taken from that CDD file. So for this project, the P2 server time is 100 millisecond and P2 star server max time is 1950 millisecond. Understood? Guys?
Yes, sir.
Okay. So now we'll apply and okay. So this is the diagnostic console created. Okay. This is the diagnostic console. And this diagnostic console is used to transmit all the services. If you want to transmit diagnostic, if you want to transmit default session, if you want to transmit programming session, okay, execute. Okay. So we'll transmit programming session. But here no response from the ECU because ECU is not connected. After 150 millisecond, it is considered as timeout. No response message received within the expected time frame. Understood?
Yeah.
P2 server time. Remember? So if there is no response from the server within, for this project, we have seen na 100 millisecond, right?
Yes, sir.
So within 100 millisecond, if there is no response, this client will consider as a timeout. No message, no response message received within expected time frame. If you want to transmit ECU reset, you can do that. Okay. You want to transmit hard reset, 1001. If you want to transmit soft reset, 1003. If you want to transmit key off on reset, sorry, 10 bol raha hu, 1102. Okay. Hard reset, 1101. Select it and execute. This message will be transmitted. Request will be transmitted. And this can be monitored in trace window as well. Okay. Here. You can able to see, yeah, here. Using 700 message ID, the client has transmitted 1101 request. Understood? Guys, 02 is single frame, 2 length, 1101, and this is padding value in the bracket. Understood? So using diagnostic console, you can able to transmit UDS related requests based on the CDD file. Okay, you can see here, based on the CDD file, you have different services. If you want to transmit this, if you want to transmit security access, you will have security access. Okay, seed request, then you'll have send key. Okay, in key, what all data you want to key value. You can select it here and can transmit. Understood? We'll do practice later once we'll complete. Okay. But for time being, just I want to make you understand this CDD file is required as the input when you are going to test UDS. Clear?
Yes, sir.
Everyone? Understandable? So just, but the thing is, you need to do frequent practice. And this tool is installed in our institute. Okay. Just go there, do practice, you'll get familiar. Got it? Guys? Got it? Okay, fine. So now, why this I'm telling now is because I was supposed to tell this in detail after completing UDS. Okay, but there was a question from your side. Why and when we are using this UDS? How we are using this UDS in actual life, right? That was the question. Right now, do you remember the last day when I was leaving Hyderabad? Guys, you are not able to understand, right? Why we are using UDS and how we can do that. How part, by seeing this tool, at least you understood little bit. Guys, there will be a client. The client is going to transmit request to the ECU. Based on the request, ECU will give some response. That part at least clear, right?
Yes, sir.
Everyone, how it is being done, how part is clear or not?
Yes, sir.
The same thing what we are doing here using Canalizer, the same thing will be done in the service center by the use of diagnostic tool. Okay. The only thing is that diagnostic tool is advanced tool. It is customized. Okay. You will not get these data, numbers, data field and all. You will get all information. Okay. That is customized tool. They doesn't need to analyze the data. They will just get everything analyzed by the diagnostic tool. The diagnostic tool will tell this issue is having this fault. Check in the manual. Simple. Because that is customized. They are using HMI interfaces. Understood? But this Canalizer tool, you will get raw data. You need to decode those information using the requirement or the input file will have, and then you need to analyze, because we are working as a developer or tester, so we doesn't get the diagnostic tool with us. We'll have this testing tool which is used in lab. Understood, guys?
Yes,
Yes,
sir.
sir.
So this how part is understood, right? How we are going to do, how the client is going to transmit some request to the ECU, and how the ECU is going to respond it. Clear? Further, I will show you example when I'll connect ECU. Okay. Currently, ECU is not connected. I'll connect the ECU and I'll give more examples how it is being done. Fine. Okay now. Then how part is you'll more understand. Now, why we are going to do that? Is it understandable or do you have still doubt? Why we are using this UPS? Guys, hello? Hello? Am I audible?
Yes, sir.
How part understood? Why still doubt? Or have you understood a little bit why we are using this UDS? Why we are using? Then somebody can you explain why we are using UDS services? How part understood, right? How the client is going to send request on CAN, and after receiving the request, ECU will do some action and will provide positive or negative response. How part it is done, right? Now, why it is being done? Can anyone explain me? Just try. If you're wrong, also not a problem. I appreciate if you'll try. Anyone? Yes, to identify fault. That is, that is one thing. And another thing also, right? For reading memory, writing memory, for doing variant coding, some other features also will be done, right? Identifying fault, rectifying fault, that is the primary thing. But apart from that, we have some other features also can be done using UDS. Correct, na? Yes. So that is the reason we are using UDS. Even for flashing the ECU also we are using, right? Some services, programming the ECU. So that's the reason we are using UDS. Is it clear, guys?
Yes, sir.
Now, okay. So now, if any doubt from your side, just do let me know. From next class, I will give some example how the client is sending request, and after he's receiving request, how the response will be coming from ECU. After connecting the ECU, I will share. Currently, I don't have ECU with me. Okay, so I'll give kind of 5-10 minutes. I'll show you. Then we'll start with another service, 28 till 27. If any doubt till now related to CAN, related to these three services, what we have seen, or related to this diagnostic testing tool, if any doubt, please do let me know. Guys, acknowledgement will be given by the who? Who will acknowledge? You just tell me. If I transmit, yes, broadcasting, but multiple nodes, all the nodes automatically क्या बोलते हैं, the CAN receiver. This is part of transfer layer, I told, right? Acknowledgement field, when I was talking about acknowledgement field. It is automatically taken care by the CAN receiver. We are not doing it, right? Automatically, if a message is received, all the nodes is going to send acknowledgement. Understood? So whoever nodes are there, not a single node, all node will transmit dominant bit during acknowledgement slot. Okay? So minimum one node should be receiving that message. Then that message will be acknowledged. Understood? Because acknowledgement error is detected by the transmitter, right? If transmitter does not detect dominant bit during acknowledgement slot, it will consider as a not acknowledged, right? Acknowledgement error. So at least one node should be there in the bus which will send acknowledgement during acknowledgement slot. Understood? And this is automatically done. That CAN receiver, CAN controller is there, that will automatically take care about this acknowledgement. Okay, we are not responsible to write code for this acknowledgement. Clear? Any other question? Guys,
Sir,
yeah,
in data frame we have 7 recessive bits now, sir.
data
End
frame.
end of frame.
End of frame. Yes,
7 recessive bits now, sir.
yes,
With the principle of bit stuffing, no, sir. 5 consecutive bits after that dominant bit, no, sir.
yes, yes. Data frame and remote frame all will have this bit stuffing concept. Okay. Only the error frame and overload frame will violate the bit stuffing concept. Or else if there is no bit stuffing injected, it will consider as a stuff error.
Okay, sir.
Okay. Error frame and
If there is
overload
no error
frame.
occur, sir.
Sorry.
In that case, any stuff error will not occur, sir.
No, no, no. Stuff error will not be there.
Why?
Why stuff error will be there? Stuff bit is already there, right? Error frame and overload frame already it's an error. It's highlighting there is an error frame. Okay.
Okay, sir.
So already it is detected as an error. So that's why it violates the bit stuffing concept. Understood?
Okay.
Only data frame and remote frame that will take as a bit stuff concept.
Okay, sir. Thank you.
Okay? Yeah. Any further questions?
Sir, how two nodes are synchronized in CAN protocol? Sir?
Sorry?
How two nodes are synchronized in CAN?
Yeah, that's a very big question and good question. For this only synchronization, we have seen what all thing? Time segment, baud rate, bit stuffing. These three concepts we have used, right? Guys, using bit timing calculation, using time segmentation. We were doing na bit segmentation. In bit is again divided into 4 segments, and then will be divided into 8 quantas. Remember? And apart from that, we have bit stuffing also. So these all three are used for synchronization of transmitter and receiver. We need to configure the baud rate. Okay. The transmitter and receiver both should be having same baud rate configured. If transmitter is transmitting it at 500 kilobaud, receiver should receive in 500 kilobaud. That is one point. Second point is automatically the bit timing is converted into segments. Okay. That will help for synchronization. Understood? Propagation segment. We have the sampling time. Remember? So that is the second thing. And the third thing is bit stuff. So every 5 consecutive bit similar polarity, there will be a stuff bit of opposite polarity for this synchronization purpose. Understood? So these three things are implemented for synchronization of transmitter and receiver in CAN. Clear?
Yes, sir.
Good. Any further question? Guys,
Sir.
further question?
No, sir.
Clear, na?
Yes, sir.
Fine. Then we'll have next class. So actually tomorrow, on Monday, Tuesday, and Wednesday, maybe we'll not have. Okay, I will try. I will post in the group because the morning Deepak sir is taking, right?
Yes, sir.